Hello, this is Hamad. I would like to represent my presentation about structural vibration control using smart materials and structure. In this part, I would like to talk about the damping system, friction dampers, and piezo damping systems, shape memory alloys, and base isolation systems. The damping system is one of the most effective systems that resists earthquake. It dissipates energy efficiently in dynamic loaded structure in the spite of severe displacement limitation. Types of damper system are, for example, friction damper system, yielding damper system, viscoelastic damping system, and visco-damper systems. In here, I would like to talk more about the friction damper system, which is installing acetate mechanic energy absorber will mostly absorb the energy that is caused from the earthquake or any other hazard. It has two types, active control and passive control. The active control dampers with the active control are highly recommended to be used in high-raised buildings that face high wind forces. The passive control, actually it's passive energy dispatch system, hosts mechanical devices that are integrated with the structure to take up portion of the load energy that applied to the structure. One of the application here I would like to talk about is pole damper, which is the X braces. It's actually to install specific materials through the bolts and the joints to reduce the load that caused by any external hazard. Next, Sumitomo device is as you see here. It's actually widely used in Japan, and devices are developed friction interface containing of graphite filled with copper that contract with steel and stainless steel. The reason of using stainless steel is to prevent any unexpected corrosion. Damper system has many advantages and less disadvantage. I would like to express the advantages that they have large capacity of energy dissipating. Moreover, the amplitude does not affect their behavior. The force can be controlled via pre-stressing normal forces. One of the good thing is the design is easy to build and not complicated, which require low technology. Disadvantage I would like to mention only like 3 of them, which is the more important things. The energy dispatch per cycle is only relative to the max displacement, not the whole displacement. High frequency is to be reduced in response, and also it can be affected by the environmental conditions such as moisture, heat, and any environmental conditions. Now I would like to talk about piezo friction dampers, which has actuator have only recently been proposed to be used in vibration isolation. Piezoelectrical is actually material can generate a significant amount of stress or strain in constrained condition when exposed to an electric field. This is really good modern technology that been used in all the world, like in Canada, United States also, as well as Japan. How does it work? It's actually the friction actuator needs less displacement and mechanical power to change the normal forces applied into the vibration material. So it requires less power and less mechanism. Before the final, I would like to talk about shape memory alloys. Actually, shape memory alloys are special materials that are able to transfer the heat energy to mechanical energy. So it's going to change its shape depends on the heat, the temperature. This wide used in application in medicine, telecommunication, airplane and piping system, as well as the structure materials. Finally, I would like to explain a bit. I will talk a bit about the base isolation system. It's actually wide used in whole the world. Like it's basically the idea of it to isolate the ground from the structure. So between the ground and structure there should be some special materials such as high damping rubber bearing or sliding system. Actually, the sliding system is not suitable for the high-rise building, but it's used perfectly in the bridges and low, like 2 floors buildings. High damping system, it's contain the rubber, as you see here. The rubber is very intensive here, so it can absorb the energy. The benefit of the base isolation system, actually, after a high intensive earthquake, there would be no remain damage to harm the structure by isolation the ground and the the structure. It's widely applied a lot of application, both bridges and structure. It's easy to maintain and easy to like can be maintained by less effort, such as easy maintenance, and by visual. You can see the building and you can see the material if it's valid or not, and it's last longer than any other materials. This all what I wanted to talk about. As I mentioned in the introduction, the damping system, friction dampers, piezo damping system, shape memory alloys, and base isolation system. Thanks for your time.